Hello guys, how are you today? So today I'll be explaining the chapter 3 CQD questions. So all the questions, exercises, questions, everything on me. So let's start. We're gonna start with the CQD number 1 grid. Calculate the concentration of H plus and the concentration of OH minus in a 0.010 molarity. This is the concentration of a solution of LiOH at 25 degrees Celsius. At 25 degrees Celsius, always remember the concentration of H plus multiplied by the concentration of OH minus is going to be equal to 1 times 10 to the negative 14 molarity. Now, LiOH can be broken into two ions, Li plus and OH minus. So looking at it, that means we found the concentration of OH minus. So this is how it works. If the concentration of the compound LiOH is 0.01 molarity, and you break it into the ions, you have one ion of Li plus, one ion of OH minus, that means each one of them has this concentration, okay? Multiplied by their coefficient. Here the coefficient is 1, here the coefficient is also 1. So here it's going to be 0.01 times 1, and here also 0.01 times 1. So like this we found what? We found the concentration of OH minus. Concentration of OH minus is equal to 0.010 molarity. Now, as we discussed above, concentration of H plus multiplied by concentration of OH minus is equal to 1 times 10 to the negative 14 molarity. Okay? So we have concentration of OH minus, which is 0.010 molarity, multiplied by concentration of H plus. It should then give us 1 times 10 to the negative 14. So very simply, to find the concentration of H plus, we can do 1 times 10 to the negative 14 divided by 0.010 molarity. And then we are going to get 1 times 10 to the negative 12 molarity. So this is what the concentration of H plus. And like that, we finished the first question. Now we move on to the second question, which is a similar idea. Calculate the concentration of H plus and the concentration of OH minus in a 0.01 molarity solution of HCl. Now, again, break this into two ions. We have H plus and Cl minus. And together, this whole compound has this molarity, this concentration. We have one coefficient here and one coefficient here. So definitely the concentration of H plus is 0.01 molarity. Okay, so like that, very simply, we found the concentration of H plus, which is 0.01 molarity. Let me write it over here. Now, concentration of OH minus, by applying the rule, we can get it by dividing the 1 times 10 to the negative 14, which we denote as Kw, the equilibrium constant of water, divided by the concentration of H plus. What's the concentration of H plus? It is 0.01 molarity. So it is 1 times 10 to the negative 14 divided by 0.01 molarity, which gives us again 1 times 10 to the power of negative 12. So like that, we found the concentration of OH minus. Now, part B, they're asking us to calculate the concentration of H plus and OH minus in a solution of 40 grams of NaOH. These are in 10 centimeter cubed of the solution. You guys should know from last year that the number of moles is equal to the concentration multiplied by the volume. Then you can mix around the equation. You can get, for example, N over V is equal to C, N over C is equal to V, stuff like this, you know? But now, let's pay attention on the important part. They want us to calculate the concentration of H plus and OH minus. First thing to do to calculate the concentration of OH minus is we're going to divide the compound. We're going to get Na plus and OH minus. So if we find the concentration of this compound, then definitely we would have found the concentration of OH minus. Now remember this equation, N equals C times V. If you move them around, you are going to get that N over V is equal to C. How do we find N? Again, from last year, N is equal to the mass over the molar mass. We are given a mass which is 0.40 grams divided by the molar mass of NaOH, you guys should know how to do it. It will be either given in the exam or you can use the periodic table to find it. And it's gonna be 40 as the molar mass. So if you do it on your calculator to find the number of moles, you're gonna get 0.4 divided by 40, which is 0.01 moles. Now, we just did the very first step, which is finding the number of moles. Next thing we are gonna do is that we are gonna substitute it in this equation over here. We have N, which is 0.01 mole divided by the volume, but remember the volume should always be in meter cubed or liters. How do you change from centimeter cubed to meter cubed? You just divide by 1,000. So now it is 0.01 divided by 0.01, which is 1 molarity. So we found the concentration of the compound NaOH, which is 1 molarity. Now, since both ions have a coefficient of 1, they will both have the same concentration, which is 1 molarity and 1 molarity. So, like this, we found what? We found the concentration of OH minus, which is 1 molarity. Next step is to find the concentration of H plus. Again, by applying the formula, you're going to get 1 times 10 to the power of negative 14 divided by concentration of OH minus. So it is 1 times 10 to the negative 14 divided by 1, which is 1 times 10 to the negative 14. So this over here is the concentration of H plus. So we finished CQD number 9. Let's move on to CQD number 10. If the pH of a solution is 5, what is the concentration of H plus? Is the solution acidic or basic? Very simply, you guys should know the relation between pH and concentration. The pH is equal to the negative log of the concentration of H plus. So if we have a pH of 5, that means 5 is equal to negative log concentration of H plus. Now, of course, if we're gonna put it like this, it's gonna be a bit confusing. So the rule we are gonna make is that this pH, if you want to find the concentration of, for example, H plus, because pH is only for H plus, so remember, if they give you the pH, they're only talking about the concentration of H plus. Never ever use the pH to find the concentration of OH minus. Always for H plus, okay? We can make a rule. What is the rule? Here, in this case, our pH is 5. So if it is a whole number or a decimal number or anything, what we are going to do is we are going to put 1 times 10 to the power of negative, and then our number, what is our number? Our number is 5, so 5. Now, if you want to check it, if you want to double check, you're going to do 5 is equal to negative log of the concentration of H plus, which we said is 1 times 10 to the negative 5. And if you do it on your calculator, you are gonna get 5. So then it is correct. So like this, we found the concentration of H plus, which is 1 times 10 to the negative 5. Now, is it acidic or basic? Definitely, if your pH is less than 7, it is acidic. If it is 7, it is neutral, which is water. And if it is basic, then it is greater than 7. So here our pH is less than 7, it is 5, so we say it is then acidic. Okay, now we move on to CQD number 12. Classify the following solutions as acidic, basic, or neutral. First things, we're gonna start with a pH of 5. 5 is less than 7, so it is acidic. 8 is greater than 7, so it is basic. And then finally 7 is 7, so it is neutral. They need us to calculate in CQD number 18 the concentration of H plus and the concentration of OH minus in a solution whose pH is 5. As we said, the relation between the pH and the concentration of H plus is always that you do 1 times 10 to the power of negative and then the number. So for the first one, the concentration of H plus is this. Now to find the concentration of OH minus, we're going to apply the rule. It is equal to 1 times 10 to the negative 14 divided by 1 times 10 to the negative 5. So it is then 1 times 10 to the negative 9. This is the concentration of OH minus. Now, if we're going to do the second one, which has a pH of 8, then it is going to be concentration of H plus is equal to 1 times 10 to the negative 8. Then the concentration of OH minus is equal to 1 times 10 to the negative 14 divided by 1 times 10 to the negative 8. And then after doing it, you are going to get 1 times 10 to the negative 6. This is the concentration of OH minus. Then for the last one, this is easy. If your pH is 7, just know that the concentration of H plus is equal to the concentration of OH minus is equal to 1 times 10 to the negative 7. You can do it in the ways we did before, but because the pH is 7 and it is a neutral, then we can apply the rule that the concentration of H plus is equal to the concentration of OH minus is equal to 1 times 10 to the negative 7. Now, we are talking, are the above solutions acidic, basic, or neutral? As we did above, if it is less than 7, it's acidic. If it's greater than 7, it is basic. And if it is 7, it is then neutral. Now, what is the concentration of OH minus in a solution whose pH is 8? We did it above, but let's do it again. First of all, the concentration of H plus, which is not what they need, but we need to find the concentration of OH minus. It's very simply 1 times 10 to the negative 8. So now to find the concentration of OH minus, we are going to do 1 times 10 to the negative 14 divided by 1 times 10 to the negative 8, and we are going to get 1 times 10 to the negative 6. This is the concentration of OH minus. Is it acidic or basic? It's definitely basic because it is greater than 7. Now we move on to exercise number 2. Acids react with bases, carbonates, and metals. Which of the following reactions produce gases? From the summary video I did yesterday, I also apologize because I did like 2 mistakes, I think, in the video. But anyways, from the video that I explained yesterday, we have acids that react with bases, carbonates, and metals. We have when acids react with bases, they form a salt and water, so salt plus H2O, liquid. When acids react with carbonates, they produce a gas, which is CO2, gas. And finally, when acids react with metals, they produce hydrogen gas. So very simply, when acids react with bases, they do not produce a gas. So definitely, it does not produce a gas. It's one of these 3 options. Next, when they react with carbonates, they produce a gas. So now it's limited to these 2 options. And finally, when they react with metals, they also produce a gas. So the correct answer in this case is C. Now, we need to write the reaction between HCl and water. If you remember, when HCl reacts in water, it will form ions, so it is a strong acid. Since it is a strong acid, it will ionize completely. So HCl gas in water will ionize completely to form H plus, completely means 1 arrow, to form H plus aqueous plus Cl minus aqueous. Okay, don't forget the aqueous. Now, for part B, we're talking about HNO3 in water. HNO3 as well is a strong acid. So HNO3 aqueous in water will form the complete ions by completely ionizing 1 arrow into H plus aqueous and NO3 minus aqueous. Now we move on to to part number C. H2SO4 and water. Now show both steps of dissociation. How does this work? H2SO4 is a strong acid. So when it dissolves in water, it will dissolve completely, of course it's aqueous, to form 2 ions, which are H plus aqueous and HSO4 minus aqueous. So remember, if you have any acid, if it is in water, it's going to give you an H plus molecule and any other molecule. In this case, we got an HSO4 minus aqueous molecule. But this is not completely broken down. So to completely break it down, we're going to do a second step. That's why it says show both steps of dissociation. The first step is this. And now the second step is what? Is that you take the HSO4 minus aqueous, you put it in even more water, but it's not strong. It's not as strong as the H2SO4. So it will partially break down. That's why we put the reversible sign, the equilibrium sign, into H plus aqueous and SO4 minus aqueous. Okay, now the final letter, we have letter D. We have CH3, COOH, and water. It is a weak acid, so it will not dissociate completely. It will, in fact, CH3COOH partially dissociate, meaning we're going to put the equilibrium sign into H plus and CH3COO minus. Now, always don't forget to put the aqueous and aqueous. So something in general we can say about this activity is when we are dissociating an acid, basically you're putting it in water so it will form ions, it will release one H plus ion and then the other thing is an ion by itself. Okay, now we move on to CQD number 31. The reaction of a strong acid with a strong base to produce salt and water is called neutralization, very simply. If you want to think of it like this, strong acid, strong base are totally opposite. So they will react with each other to form water, and water is neutral, so they neutralize each other, so we call it neutralization. Now, they told us some reactions of substance M over here are shown below. It reacts with magnesium, a metal, to form hydrogen. Okay, this means definitely it is an acid. It reacts with sodium carbonate, a metal carbonate, to release carbon dioxide. This is further proof that it is an acid. And we know in an acid it contains H plus ion. Then it reacts with copper oxide to form copper chloride. But where did the chloride come from? Very simply, it is the chloride ion. So substance M is H plus and Cl minus, which is HCl, which is hydrochloric acid. Okay? Now we are going to move on to CQD6. Now, if the burette was filled with dilute hydrochloric acid, we have an acid, and the solution was slowly added to a conical flask containing dilute sodium hydroxide solution. So what happened is that we have originally a base, NaOH. Then we added to it an acid, so it neutralizes. Okay, but before it neutralizes, it's going to take some properties of the acid. So they're telling us what is going to happen if we had sodium hydroxide and then we add a base and then we added an acid to it. Originally, it was a base, and base in the litmus indicator is blue. However, because we're adding an acid, it will slowly turn to red, because a red in litmus is acid. Now, methyl orange, if it is a base, then it is yellow, and since we're adding an acid, it will slowly turn red. Now, thymolphthalene is used from, now in a base it's gonna become blue, and in an acid it is always colorless. And now finally, phenolphthalein is used from, in a base it is pink, and in an acid it is colorless. So now this is CQD6 done. They told us when a drop of universal indicator is added to acetic acid, an acid, okay? A universal indicator, the colorless solution turns orange. They already gave us the answer. Okay, so look at your options. You have red in the universal indicator. You have red, then orange, then green, then blue, then purple. What do each of them mean? Red means extremely acidic. Orange is not too acidic, but it's also acidic. Green is neutral. Blue is not too basic, but it is a base. And then finally, purple is extremely basic. Okay? So then they told us they added a drop of universal indicator to sodium hydroxide, NaOH, which is a really strong base. So the colorless liquid turns to purple. Now we go on. When a drop of universal indicator is added to water, it will definitely become green. Now we move on to CQD 30. Now they're asking us which of the following produce a gas. First of all, an acid plus a base gives us a salt and water. We call this a neutralization reaction, so it does not produce a gas. Then a base and an ammonium salt. It will form ammonia gas, NH3 gas, plus water, H2O. Not I was trying to write water, so let me just write water instead. Water, okay? So it definitely produces a gas because ammonia is a gas. Then an acid plus a metal carbonate will produce carbon dioxide gas plus water plus a salt. So definitely it's producing a gas. Acid plus a metal produces H2 gas, hydrogen gas, in addition to water. Not water, in addition to a salt. So definitely it produces a gas. Now, acid plus a metal sulfide, it will produce a salt and water and sulfur dioxide, SO2. So it will also produce a gas. Now, acid plus metal oxide will only produce a salt plus water. Literally, A and F are the same thing. Let me not circle them in red, let me circle it in blue. A and F are the same thing. They are both a neutralization reaction because a metal oxide is a base, okay? And don't forget, a non-metal oxide is an acid. So if you're doing an acid plus a base, which is a metal oxide, it's gonna produce salt and water, which is not a gas. So the only four answers are B, C, D, and E. So that is it for CQD number 30. Okay, which of the following elements is most likely to form an acidic oxide? An acidic oxide is a non-metal plus oxide. So it has to be a non-metal that will react with oxide, okay? We know that the metals are found to the left and non-metals are found to the right. So immediately we remove these two since they are on the left. Now we come over here to the right. We have C and D, but D is in the last group, which is noble gas group that does not react with anything. So we cannot choose D since it will not react. So instead we are going to choose C. So C only. All right. Now we move on to CQD number 2. Which of the, consider the following: aluminum oxide, calcium oxide, carbon dioxide, carbon monoxide, magnesium oxide, and sulfur dioxide. Now very simply, we know that aluminium oxide is amphoteric. Calcium oxide is a metal plus an oxide, so it is basic. Carbon dioxide is a non-metal plus an oxide, so it is acidic. CO, we know it is neutral. MgO is a metal and an oxide, so it is basic. And then finally, SO2 is acidic because it is a non-metal and an oxide. So, which of the following can react with an acid but not a base? For it to react with an acid, it has to be basic or amphoteric. But since it's not reacting with a base, it cannot be amphoteric. It can only be basic. Okay, so which ones are the basic? We have CaO and MgO. Next one, it can react with a base but not with an acid. That means it has to be acidic. Which ones are acidic? We have CO2 and SO2. It can react with both basic and acidic. It is amphoteric, so Al2O3. And then finally, it cannot react with the acid or the base. That means it is neutral, so it is then CO. Now we go to CQD3. Now remember, if it's a metal and an oxide, then it is basic. If it's a non-metal and an oxide, then it is acidic. Metal, oxide, basic. Now N2O is neutral. Remember, it looks like H2O. H2O is water, it's neutral. So N2O is neutral. CO is also neutral. ZNO is amphoteric. SO2 is non-metal plus an oxide, so it is acidic. Al2O3 is amphoteric. And then finally, CaO is a metal and an oxide, so it is then basic. So that's CQD number 3 done. Now we move on to exercise 4. Element X is on the left side of the periodic table. Which of the following is true? If it's on the left side of the periodic table, then it is a metal. And a metallic oxide, a metal oxide, is basic. So B is correct. So now we move on to complete the equations. We're starting off with CaO solid plus H2O liquid. A metallic oxide is basic, so it will become a base. And a base using calcium is CaOH. Now if you're gonna make it into its ions, okay, it will it is a weak base, so it's not gonna fully dissolve. It will partially dissolve, or like it will not fully ionize. It will partially ionize into Ca2 plus aqueous and 2OH minus aqueous. Now, if we are going to talk about SO3 and H2O liquid, it is going to be definitely, it's a non-metal plus an oxide, so it's going to be an acid. And then an acid we can make from this is H2SO4, and it's a strong base. Sorry, not a strong base, a strong acid. So it will dissolve into H plus, actually 2H plus, in addition to SO4 2 minus. I know in the questions answers it says that it's partially gonna dissolve, but no, it fully dissolves because it is a strong acid. The second part of the equation, yes, it partially dissolves, but now if we're talking about it as a whole, no, it will fully dissolve. Now if we move on to number 3, CO2 plus H2O, again it is gonna be an acid because it's a non-metal plus an oxide. The acid we can make from this is H2CO3. And here this one is a weak acid, so it will partially ionize into 2H plus aqueous plus CO3 2 minus aqueous. Now if we are talking about part D, we have SO2 minus plus H2O liquid. Again, this is an acid, so it's gonna be H2SO3. Now this is not a strong acid, it's a weak acid, so it will partially ionize into 2H plus aqueous plus SO3 2 minus aqueous. Now we are reaching again to the bases. We have K2O and H2O liquid. It will form 2KOH. How did we know? Because we thought about a very famous base that has K and OH. It is KOH. So then you balance it and you get 2KOH, and it is a strong base, so it will fully dissolve into 2K plus aqueous plus 2OH minus aqueous. Now finally we have Na2O and H2O. Again, we're going to think of a base that has Na and OH. It is NaOH. So then balancing it, you're going to get 2NaOH. And it's a strong base, and it's going to dissolve into 2Na plus 2OH minus. Okay, now let's move on to CQD22 top. A gas reacts with both potassium hydroxide and sulfuric acid. Which of the following is true about X? It reacts with potassium hydroxide, KOH, and sulfuric acid, H2SO4. So it's reacting with an acid and a base. That means it is amphoteric. Now, CQ solution of concentrated hydrochloric acid, this is an acid, is added to an aqueous solution of sodium carbonate, Na2CO3. Acid added to a metal carbonate will definitely release carbon dioxide plus water plus a salt. Okay? Salt is either soluble or insoluble. Now, what is the expected observation? First of all, because we're releasing CO2, there is going to be effervescence. Okay? The net ionic equation, this is how we are going to do it. We're going to have H plus. We're going to take each ion as it is, H plus Cl minus plus Na plus CO3 2 minus. Now, of course, we have to balance them all. They all have one ion, whereas this has two ions. So to make them all balanced, we're just going to put a 2 over here. So now you have 2 positive ions, 2 negative ions, 2 positive ions as well. Now it's going to be balanced with the CO3 2 minus. It is going to give us a salt, but it's a soluble salt because it's going to be Na plus and Cl minus. So 2Na plus Cl minus will stay as it is because they are soluble. In addition to H2O, we said water and carbon dioxide. So now, what we find common on both sides, we are going to cancel them. So this and this, and this and this. So if they're the same on both sides, then we cancel them. And we are left with 2H plus 2Na plus, my bad, I apologize, no. It's 2H plus CO3 2 minus, which will give us water, H2O, plus carbon dioxide. This is the net ionic equation. They need only the things that form solids, you know, that do not form ions. So you add this to this, it will form water and carbon dioxide. When I said solids, I didn't mean solids. I mean something that's like physical, not an ion. So this over here is the net ionic equation. Now we move on to CQD number 15. We need to write down the complete acid-base equation of the following. We're doing a neutralization of an acid and a base. Very simply, acid plus base will give us salt and water. Very simple. Carbonate ion in water. Carbonate ion is CO3 2 minus. Do this is we are going to separate them into their ions. So CO3 2 minus is already CO3 2 minus. H2O separated into its ions, it is a 2H plus OH minus. Okay, now you're gonna switch the anions and cations. This does not have a cation, so you're just gonna give this to it, and this will remain on its own. So now it will become what? It will become HCO3 minus, because it is not fully, this is how it is as it is in chemistry, HCO3 minus, in addition to OH minus. And of course, don't forget to put the aqueous. Now we move on to sodium carbonate. It is a metal carbonate, which is a base reacting with a strong acid. Very simply, sodium carbonate is NaCO3, actually Na2CO3, in addition to a strong acid, let's say HCl. We know base plus acid gives us salt and water. Now they need the net ionic reaction. So the net ionic reaction, what we're going to do, we're going to separate them into their ions. We're going to have Na plus, actually 2 Na plus, in addition to CO3 2 minus, plus this needs to be 2 so it can balance. Then it's going to be 2H plus, in addition to 2Cl minus. Oh, and I almost forgot that it also releases carbon dioxide. Now, what do these release? They release a salt, which is a soluble salt in this case, which is 2Na plus 2Cl minus, in addition to water, H2O, and CO2. Now, we cancel out the ones that are the same on both sides, and this. And so now we are left with the net ionic equation being CO3 2 minus plus 2H plus is going to give us H2O liquid plus CO2 gas. Now, an ammonium ion in the water, ammonium ion is an H4 plus in the water, which is H2O liquid. What will it produce? We know, first of all, it is a partial ionization because ammonia is a weak base. So then an ammonium ion is going to be a weak ion or a weak electrolyte. So very simply, we can break H2O into its ions, which are H plus and OH minus. So now, one thing you guys have to know is that the OH minus, when it reacts with the NH4 plus, it's gonna reduce the H of it. So it's gonna be NH3 now. So one of the products we're gonna get is NH3, which is ammonia gas. In addition to, now where will this extra H go? It will go to this over here. So if it was H2O, it's then gonna be H3O plus. So think of it like this. So the OH minus is gonna take the H plus from the NH4 plus, okay, and it's gonna put it in the H2O. So it's gonna take the H and put it into the H2O. So it's gonna be NH3 plus H3O plus, okay? Now we move on to part D, which is a strong base and ammonium salt. A strong base, for example, NaOH, and ammonium salt, which is NH4 plus. We said it's a strong base, so it's one direct reaction. It will fully ionize. The OH minus, break this into its ions. It's Na plus and OH minus. The OH minus is gonna take an H plus from this, and it's gonna bring it here. So now it's OH minus plus H plus. So we're gonna get water, that's H2O. In addition to, the Na will become dissolved, we don't need it, and now we are left with NH3. Or you can do it very simply by saying that NaOH is a strong base reacting with an ammonium salt, so it's gonna give us water plus NH3. Now part F, CaO, which is a metallic oxide, so a base reacting with 2H plus. CaO reacting with 2H plus, it is gonna give us a full reaction. Let's break them into their ions. This becomes Ca plus and OH minus. But now, like you see, chemistry is all math. Where did you get the OH minus from? This is the ion that contains O. OH minus is the ion that contains O. But if I'm gonna add it to the 2H plus, it's definitely gonna give me, first of all, it's gonna leave me this ion, Ca plus, and give me water. Okay, so it's all about like mixing and matching and math in chemistry. Now the last one we have, which is SO3 gas, in addition to NaOH aqueous. Let's break them into their ions. This SO3 gas, it cannot be broken into its ions, so it's SO3. For now, it cannot be broken because it's not dissolved in water. Plus NaOH aqueous, it can be broken into Na plus and OH minus. But if you remember, we took the ion of SO3, or the ion that gives us the gas SO3, which is SO4 2 minus. It has a 2 in the charge. It's 2 negative. So to balance it, we need to give 2 to all of the ions. Okay, so it will give us a full reaction because NaOH is a strong base. It will fully ionize, okay, and it will give us 2 Na plus. It will stay as Na plus. In addition to this gas comes from SO4 2 minus, so SO4 2 minus and water. Now they're asking us for the net ionic equation, so what we're gonna do is we're gonna cancel the things that are the same on both sides, and then our net ionic equation is SO3 gas in addition to 2OH minus will give us SO4 2 minus and H2O liquid. Now we move on to the salt preparation, CQD number 8. They need us to calculate the final concentration of H plus and concentration of OH minus. Okay, the very first thing we're gonna do is break it into their ions. We have Na plus, OH minus. Then here we have H plus and Cl minus. Now, let us calculate their concentrations. First of all, the concentration of NaOH, we know that N is equal to C times V. We have C, which is 1 molarity, times V. We need to change it to liters, so you do 200 divided by 1,000, and you're going to get 0.2. So the number of moles of NaOH is 0.2 moles. In the answers, it says 200 millimoles, so this is not something we took yet. It's just like conversion unit. Just keep it in moles, 0.2 moles. And then if you're gonna find the concentration of HCl, it's N is equal to C times V. C is 1, and again V is 0.2, so again 0.2 moles. Since they are the same amount of moles, by the way, I said we need to find the concentration. I'm really sorry, I meant to say we need to find the number of moles. Okay, we have 0.2 moles and 0.2 moles. Since they are both the same amount of moles, this means they're gonna finish each other up. There will be nothing left, so there is no excess and no limiting. If they use each other up, that means it's gonna become neutral because none of them is in excess. Okay, now if they are neutral, what does this mean? This means that the concentration of H plus is equal to the concentration of OH minus, which is equal to the radical of constant equilibrium constant of water, which is 1 times 10 to the negative 7. And that's it, very simply. Another way you could do it is that you have NaOH, which is a base, and HCl, which is an acid, and you calculate then the number of moles. Okay, you will see that number of moles are equal to each other, and you know that because they are equal in each other, there is no excess, so it's going to be base plus acid, and we know this is a neutralization reaction. Neutralization reaction means water. Water means concentration H plus equals concentration OH minus. Now we go on to the next question, which is which of the following is the best method to prepare ZnSO4, which is a soluble salt, from H2SO4 and ZnO? First of all, do we have the cations Na plus or K plus or NH4 plus? No, we do not have. So we are going to be using the excess method. Excess method meaning you are going to add. Okay, but which excess method will we be using? If you go up to the table, I think over here, not the table, the diagram over here, they said you use the titration method when we are talking about Na plus, K plus, and ammonium salts, which is NH4 plus. So we do not have any of these ions. We're not gonna use it. However, we have another salt which does not include ions. So we're gonna be using an excess method where we react the appropriate acid, a proper amount of acid, with extra metal oxide, hydroxide, or carbonate. So this is what we have in exercise 5. It was over here. We have an acid in addition to a metal oxide. So we need to add a specific amount of acid and into excess metallic oxide. So the correct answer is D. Excess ZNO to acid solution. Now, let us go to exercise 6. Copper sulfate solution was prepared by reacting excess copper oxide with dilute sulfuric acid. So we have an excess of a metallic oxide with a sufficient amount of acid. This is definitely an excess method. So we need to fill in the blank. I don't think there is any answer key for the exercises, but I'll try my best to fill in the blank. I think this is excess copper oxide, CuO, exercise 6 as well. Okay, so in exercise 6, we have copper sulfate solution was prepared by reacting excess copper oxide, CuO, with dilute sulfuric acid, H2SO4. Let's label the diagram. First thing, you are adding excess, I'm not sure if this is correct, but I think this is the volume of acid, because here they said CuOS added till all the acid reacted. So this is excess CuO solid, and this over here is heat. So I think this is the labeling of the diagram. I'm not sure about it though. So please double check if you can for exercise 6. Now exercise 7. Oh, there's part B, my bad. They said explain what is meant by excess. Excess means that all the acid is used up and there still remains the copper oxide. Draw a diagram to show how the mixture is filtered. Very simply, you draw the conical flask, draw the filter paper, then draw a beaker pouring out the solution over here. And then draw in here, this is the filtrate, and in here, the solid is the residue. Exercise 7. The pieces of apparatus needed during the preparation of sodium chloride, NaCl, by titration are, whenever we're using titration, we definitely need some specific things, which are beakers, flasks, pipettes, and burettes. So you have to look at the thing that has a beaker, okay, or a flask. A flask could work, a beaker could work, and a burette and a pipette. So C works. So as long as it has a beaker, a flask, a pipette, and a burette, then this is what titration works. Now we have CQD number 5. We have method A using a burette and an indicator. Then this means this is used by titration. Okay, method B, mixing two salts to obtain a salt by precipitation, precipitation reaction, addition of an excess base or metal to a dilute acid, then removing the excess filtration. This is a neutralization reaction, so acid plus metal. Then this is acid plus metal oxide. Then we have metal carbonate . and acid. Okay, so for the following salt precipitations, do the method, name any reagent needed, and complete or write the reactions. They said name, so we're not supposed to give their chemical formula. You can, but it's preferable you give their name. At least that's what my teacher told me. Now here we have zinc sulfate, which is a soluble salt. So we're definitely not using precipitate, we're using neutralization, or acid on metal, or metal carbonate, or titration. We'll see which one. Now it is zinc sulfate, ZnSO4. Does it contain Na+? So since it does not contain Na+, K+, or NH4+, we are not going to be using titration. Next step, it is zinc oxide. So we are going to definitely be using metal oxide. So we are going to be using, okay, so CQD number 5, method A, using a burette and an indicator. This is titration. Method B, mixing two solutions to obtain a salt by precipitation. This is precipitation reaction. Addition of excess base or metal. This is neutralization. Addition of an excess metal oxide to a dilute acid, then removing the excess by filtration. This and D and C are almost the same because any metal oxide is a base, so they are the same, method D and method C. So I'm gonna just say here metal oxide plus acid. Addition of excess metal carbonate to a dilute acid, then removing the excess by filtration. So this is metal carbonate and then removing the excess by filtration. So metal carbonate plus acid. In my opinion, D and C are very similar. So the soluble salt zinc sulfate, ZnSO4, from the insoluble salt zinc oxide, ZnO. So the method can be either C or D. I prefer going with C because this is how they went with in the answers, the answer key. Now the reagent, which acid has SO4 in it? H2SO4. Now the word equation is zinc oxide in addition to sulfuric acid will give us zinc sulfate and water. Okay, now the soluble salt potassium chloride, from the soluble base potassium hydroxide we have K+, so we're going to be using titration, and I believe method A was titration. Okay, soluble base potassium hydroxide, KOH. Now we have potassium chloride, which is KCl. Which acid has Cl in it? It is HCl. Now they didn't say the word equation, they said the equation, so it's going to be KOH plus HCl gives us KCl plus H2O. Neutralization reaction. Insoluble salt, directly, which method? Method B, precipitation reaction. It is lead iodide, PbI2, from the soluble salt lead nitrate, L. Lead is not L, it's PbNO3, 2. Now we're going to think of anything soluble that has I in it. It can be anything. It can be NaI, it can be LiI, but one they used in the answers was Ki. Now if you were to write the full equation, okay, it's gonna be not P, sorry, it's gonna be Pb2 plus 2I minus, it will give us PbI2 aqueous. Now we go down to D. They said name. Name means give the name, not the chemical formula. The chemical needed to be added to insoluble magnesium oxide, MgO, to form magnesium sulfate, MgSO4. We have a base, we need to add an acid to the base. So which acid contains SO4? It is HSO4. Don't write the chemical formula. In words, it is sulfuric acid. Now, which method can be used to prepare the soluble salt potassium chloride? Again, K+. When we're talking about K+, we're going to use titration, and I believe method A was titration. Name the chemical needed to be added to lithium hydroxide, LiOH, to form lithium sulfate, LiSO4. Very simply, LiOH is a base, so we need to add an acid to it. And which acid contains SO4? It is sulfuric acid. Which method can be used to prepare insoluble salt? Directly insoluble salt is method B, which is precipitation. The chemical needed to be added to silver nitrate, AgNO3, to form silver chloride, AgNO3, and we need to form silver chloride, AgCl. You can think of anything with Cl, for example, salt and ACl. Which method can be used to prepare the soluble, first of all, salt, magnesium sulfate, MgSO4, from the insoluble base, magnesium oxide, MgO. Here, as I said, you can use either C or D because they are the same thing. Here they use D. If you put C, it is also correct. We need to name the chemical used to be added to insoluble calcium oxide, CO, to form calcium nitrate. Calcium oxide, sorry, is CaO, to form calcium nitrate, which is CaNO3. Okay, you need to think of anything with nitrate in it, any acid, because it's a base. Very easy one is nitric acid. Which method can be used to prepare the soluble salt? Sodium iodide. Directly we have Na+, so we're going to use method A because it's titration. Name the chemical needed to be added to sodium hydroxide to form sodium chloride. Very simply, sodium hydroxide is a base. Sodium chloride is NaCl. If we're going to add to a base, it needs to be an acid. So any acid that has Cl, it is HCl. But I gave the chemical formula. You need to give the name, which is hydrochloric acid. Now, if you go down, there's still M and M. Which method prepared the insoluble salt, Pb iodide, Pbi2, from the soluble salt, PbNO3? Directly insoluble salt means titration, and titration was method B. Now, finally, name the chemical added to PbNO3 to form Pbi2. You can think of anything with iodide in it. It can be Ki, for example. Don't say Ki, say potassium iodide. In the example, in the answers, they gave sodium iodide as an example. Now, CQD 26. Which of the following reagents can be added to hydrochloric acid, HCl, to prepare zinc chloride, ZnCl2? Very simply, HCl and ZnCl2. We got Cl from here, and Zn, where did we get it from? From one of these options. So first thing, our first condition is that it has to have Zn. Our second condition is that it has to be a metal, a metallic oxide, or a metallic carbonate. So that leaves us with three options, A, B, and C. These are the correct options. Next, which of the following reagents can be added to sulfuric acid, H2SO4, to prepare copper sulfate, CuSO4? SO4 came from here. Copper came from this. But here is the thing. For copper and silver, you cannot use them as pure metal form because they will not react. So it has to be copper oxide, copper carbonate, copper hydroxide, you know, anything other than copper itself. So it's going to be B, C, and D. Number 28. Which of the following reactions produce ammonia gas? Ammonia gas comes from the ammonium salt reaction and the base. So the answer is B. Which of the following reactions produces a pungent smelling gas? So we are releasing ammonia that turns damp red litmus paper blue. This is ammonia then. Which of them releases ammonia gas? It has to have the ammonium salt, not this one, not this one, not this one. This could be and not this one. So our answer is then D. CQD number 30. Which of the following produces a gas? Definitely not acid and base because it's a neutralization reaction, but ammonium salt and base releases ammonia. Acid and metal carbonate releases carbon dioxide. Acid and metal releases hydrogen. Acid and metal sulfite releases sulfur dioxide. And then definitely not this one because it is also neutralization. So B, C, D, and E. Now we go on to CQD 32. During precipitation of silver iodide, AgI, by precipitation, what is the correct order of steps? Very first thing you need to do is mix the two solutions. After mixing the two solutions, you need to stir with a glass rod to see if there is any excess. After stirring it with a glass rod, you need to filtrate it, and then after filtering it, you need to dry it, okay, in an oven. Never with the papers, because the papers may smash it, okay? CQD 33. The pieces of apparatus needed during the preparation of sodium chloride, NaCl, by titration. When we're talking about titration, we said you use either a flask, a beaker, a burette, or a pipette. So again, this is number 33. And number C, CQD 33. I think they repeated it twice. CQD number 34. They gave us the answer already, as well for CQD 35. And CQD 36, they already gave us the answer. So these three, they already gave us the answer. We can skip them. Okay, the information in the box is about preparation of magnesium nitrate crystals. Step 1, add spatula measures of magnesium oxide to some hot dilute nitric acid, then stir. Step 2, continue adding magnesium oxide until it is in excess. Step 3, remove excess magnesium oxide so that colorless magnesium nitrate is left behind. Step 4, evaporate the magnesium nitrate solution until it is saturated. Step 5, leave the saturated solution to cool while crystals are seen formed on cooling. Step 6, remove the crystals from the solution. Dry the crystals on filter paper. Now, part A, explain why excess magnesium oxide is used in step 2. This is to use up all the acid. So, use up all acid. Part B, explain how excess magnesium oxide is removed from the solution in step 3 by filtration. Because it is excess, it's gonna stay as a solid. Now, what is meant by the term saturated solution? The term saturated solution, I'll not write it because it's long, it means a solution in which no more solute can dissolve in the solvent at a specific temperature. So remember, saturated solution is a solution in which no more solute can dissolve in the solvent at a specific temperature. What is the practical method that should show that the solution is saturated? Very simply, you have two ways of doing this. You can either add more magnesium oxide, or you can dip a cold glass rod. Okay, for part D, two ways, but the preferred way is to dip a cold glass rod. Explain why the crystals in step 7 are dried using filter paper and not by heating. If you heat it, it might break down. So to prevent breakdown, and also if you heat it, you are gonna lose the water, and to prevent loss of water. Now, filter paper is like more accepted for this one, whereas in the other one we used an oven because the oven would dry it instead of crushing it, you know, because if we dried it with the filter paper, it would crash. They would crash with each other and break. Now we move on to CQD 23. Okay, I'm not gonna read, but in part A, they asked us what is the concentration of sulfuric acid solution. They gave us the steps to make it easy for us. They told us, first calculate the number of moles of calcium hydroxide. Very simply, we are gonna do the concentration multiplied by the volume in meter cubed. So 25 divided by 1,000, that becomes 0.025. Okay, if you multiply them together, you are gonna get 1.25 times 10 to the negative 3. This is the number of moles of calcium hydroxide. Now, calculate the number of moles of sulfuric acid to react completely with calcium hydroxide. It should be the same if it's gonna react completely. So 1.25 times 10 to the minus 3 should be the same. Now calculate the concentration of sulfuric acid solution. We have that the number of moles is 1.25 times 10 to the negative 3, and they told us that the volume of sulfuric acid is 12.5 centimeter cubed. So change it to meter cubed. 12.5 divided by 1,000, you're gonna get 0.0125. So if we're doing 1.25 times 10 to the negative 3 divided by 0.0125. Doing it on the calculator, we are going to get 0.1 molarity. And we calculated the concentration of sulfuric acid. Now, after titration is done, the final solution in the beaker contains solid calcium sulfate, water, and some acid-base indicator. Describe how to extract the dry sample of solid calcium sulfate from the solution. Write the process including all key steps. Very simply, you're first gonna perform a filtration to remove the CaSO4. Okay. After that, you are gonna rinse the filtrate with distilled water. After that, you're gonna place it between either two filter papers to dry gently. Do not move it, otherwise you will crash it, or it's preferable to place it in an oven. Alright, part C. The student conducted the following test on products of the reaction between sulfuric acid and sodium carbonate. Sulfuric acid is what? H2SO4. Sodium carbonate is Na2CO3. If they did a flame test, then the Na would react and give them a not red, my bad, a yellow flame. If you pass the gas in lime water, it will turn milky because the carbonate will release carbon dioxide. Okay? Now, if you add barium nitrate when it reacts with SO4, barium when it reacts with SO4, it will form a white precipitate. Now, part D, dilute sulfuric acid reacts with the metals, metal oxides, and bases. Write the chemical equations for the reaction of sulfuric acid, which is H2SO4, with magnesium. Just do magnesium plus H2SO4. It will give us MgSO4 plus H2. Then sodium oxide plus H2SO4 will give us Na2SO4 plus H2O. And then finally, potassium hydroxide plus H2SO4. Okay, so potassium hydroxide plus H2SO4 is going to give us K2SO4 plus 2H2O. Now, if we're going to go to CQD 24 top, both repeat 2 times. I'm not sure why, but it's okay. So we're going to start with 24 top. Student conducts an acid-base titration to determine the concentration of a sodium hydroxide solution using a 0.1 molarity hydrochloric solution. He's provided with the following apparatus. Name the items the student needs to perform the titration. He needs B, which is a conical flask, D, which is a burette, and E, which is a pipette. He can also use a beaker, but here we do not have a beaker. B. The student adds few drops of an acid-base indicator to 20 centimeter cubed of sodium hydroxide and titrates the mixture with the hydrochloric acid solution. Why is it necessary to add an acid-base indicator before starting the titration? This is like when we need to neutralize it, okay? We put the acid-base indicator so that it can indicate when it is neutralized, okay? When it's neutralized, it will turn green. So you can write it indicates the end point of neutralization, or it indicates when it reaches neutralization by changing the color of the solution. 2. The student makes 2 readings to determine the volume of the hydrochloric acid needed to neutralize completely the sodium hydroxide solution. The initial reading he made before starting the titration is 10 centimeter cubed, and the final reading at the end of the titration is 23 centimeter cubed. What's the volume of hydrochloric acid used to completely neutralize this? Very simply, you should do, if you're doing hydrochloric acid and base, because we're using NaOH and hydrochloric acid, you should do that concentration base times volume base is equal to concentration acid times volume acid. But then again, there are some cases where they trick you, okay? Usually when you see base and acid, okay, and they ask you to find the volume and the concentration and stuff like this, you use this equation. But then again, if you read the question 2 times and don't directly assume like I did right now, what you're supposed to do is we have 23 centimeter cubed. This was the final volume. So final volume minus the initial volume, which was 10 centimeter cubed. It is going to give us 23 minus 10, which is then 13 centimeter cubed. This is the volume of acid needed to neutralize the sodium hydroxide solution. Now we move on to part C. The student repeats the experiment using the same materials. He discards the content of the final solution from the flask and he refills it directly. There's a mistake he did. He did not rinse it first. He should rinse it, okay? He should rinse it with distilled water so that he can repeat the experiment again. So what did the student do wrong? He did not clean the flask. He did not rinse it. Describe the procedure. He should rinse it with distilled water. Now 24 top, which I believe they meant 25 top. Plan an experiment to find the concentration of an aqueous solution of sulfuric acid provided with dilute solution of sodium hydroxide of known concentration and common laboratory apparatus. Very simply, here is where we're going to apply concentration acid times volume acid is equal to concentration base times volume base. But we need to apply it in the experiment. How are we going to do this? First thing, we're going to fill a burette with the base. So fill burette with the base. Okay? After filling the burette with the base, you need to measure a known volume of sulfuric acid. Measure known volume of sulfuric acid. And then place it in the flask. Place in flask. After this, use a suitable indicator. Suitable indicator. Okay? Then, slowly, but not too slowly, but slowly add the base while stirring. So don't forget stirring. Okay? Then record changes. And now, to find the volume of the base added, you can do volume final minus volume initial. This is to find the volume of the base added. You do the volume final minus volume initial. And then now to find the concentration of the acid, you know the volume first of all of the acid. Let's circle the ones in blue, the things we know. We know the volume of the acid. We know the volume of the base. How? By doing V final minus V initial. They told us we have a known concentration of the space, so the concentration is known. So we can use these three to find the concentration of acid. And that's it for this video. Thank you guys for watching. I hope you have a wonderful day and do well in your finals.